Hi all, welcome to our AWS Networking and Security course. Today I'm going to give in-depth details of networking and security in AWS. As we engineers know about how networking works and security works, in AWS we are going to see the networking and security concepts and how to implement our cloud networking in the AWS cloud. We know our traditional network, how we work in a data center of organization. There we routers, switches, and servers, and racks, and so many things we see there. In a traditional network of organization, there we see the routers and it connected to the switch. Ultimately, the servers are connected, and servers are configured with the web services, and some of servers are configured with application services, then database services, and these are some of the servers are exposed to internet, where the customers can access the services. So this traditional network is a physical location where these networking devices and security firewalls are interconnected, and we design in such a way that these are connected, each other physically. So as the today's world are moving to cloud, we need to focus how this can be developed in the cloud area. So if my organization want to move to cloud, for example, AWS is one of the topmost cloud provider. As a network engineer or as an architect, I should be familiar, or I should know how to design this network, just like how I designed and implemented physically in my organization's data center. Okay, when you talk about cloud, the network, is deployed in a provider area. Like AWS, they have several locations. For example, if you take Mumbai is a location. Within Mumbai, they do have one or two availability zones. Okay, so in a physical location, they have called as a region, and within the region, they have availability zones in order to provide the availability. Like if one data center goes down, then the other one will be available. So to provide the best cloud services, they do have concept of zones and region and availability zones. Okay, so this diagram I just shown you how you interact with your organization network, like routers for connecting different VLANs and passing the traffic to the internet, and how our servers are secured by the firewall, and how those are connected to internet. Okay, so these things you are already aware. So when you come into AWS networking and security area, you need to think everything in a cloud. Okay, so how I design the technical architecture with the routers, switches. In same way, with a different time, we are working in the cloud area. So when you talk about AWS cloud, the networking components are different from the traditional one. Okay, so as I said, in a physical location, they have a different availability zone. That is nothing but a cloud data center. In our point of view, it is called as virtual private cloud. Okay, so this VPC is nothing but place with different data centers are interconnected. And there we have the networking components like subnets, gateways, and VPN endpoints and various other things. Okay, so if I run my corporate network with the physical devices, for the purpose of migration or for different reason, I need to connect to this AWS cloud. Okay, with a VPN connectivity or a direct connect, something like that. Okay, so we are going to see these things in details. So as you're aware, the VPC, okay, represents our custom networking, where I can design my network according to my company requirement, and I can deliver effectively by following the security standard of my organization. So this virtual private cloud, we can use different components, and you can design the network as an architect and deliver the services. So today we are going to see different networking components. These different networking components, how it works, what are their purposes, those as well we are going to see. Okay, so let me just show you console Amazon, how it looks like. So as you already know about the Amazon Web Services basics, I'm going to take you to the VPC. So this is the VPC is the key thing where we design our network with the different tools. Okay. Now, if I go to my virtual private cloud and VPC, so what it shows here, without designing anything, okay, by default, the AWS will give some of the tools which is pre-configured and readily available to deploy my server directly. Okay, but as an architect, I want to go with custom design. For that I need to create whatever the things is required newly. Okay, so by default, this AWS VPC is ready to provision a server with a predefined configured networking. As you see here, it says it's a default VPC, and it shows 172.168.0.0/16 CIDR range. And under this /16 CIDR range, I can see those are classified with different subnets, which is nothing but subnetworks with the /20/20/20. Okay, which has the number of hosts 4091. Okay, so I can deploy 4091 servers or machines in each subnet. Okay, so it also says this subnet resides in this availability zone in this region, and this subnet is in this availability zone. So nothing but another availability zone and the third availability zone. Okay, so according to the region, you will see the number of availability zones are more or less. Okay, which is provided by AWS. So I can see the route table also, which is a default, and the internet gateway. Yeah. So some of the standard things I'm seeing here. Okay. So this one only we are going to look into it in detail, and I'm going to show you how to define this custom VPC and custom subnets and custom route table, and how to deploy my server in that particular custom subnet, and how to enable the routing between them. Okay, so when we talk about this networking, we need to be familiar with the networking concept called subnetting. Okay, so always we refer the IP ranges with the /CIDR ranges. Okay, so what is this CIDR? So classless interdomain routing is nothing but uh, dividing the IP subnets according to our requirement from class A or class B, class C. Okay, so in the college days, you might have learned this subnetting, how to do the subnetting with formulas. I'm going to show some of the things briefly to recall. Okay, how subnetting works. Okay, now let me give an example. So, as you all aware, this class A, class B, class C, uh, class C IP addressing, which has different values. So, if you take class A, it is nothing but /8 CIDR. So, what is this /8 CIDR? That means 255.255.255.0. This is called subnet mask. Okay. Uh, I'm sorry. Uh, since it is /8, it should be 255.0.0. Okay. So this is called a network portion, and this is called a host portion. Okay. And if I take class B, then the subnet mask in the CIDR notation, it is /16. That means the network portion is like this. Okay. So /16, occupies this network portion. Then let's come to class C. It is /24. So what is this /24? That means the network portion will be like this. Okay. So what it exactly represents? If you go through this subnetting formulas, it is identified as binary with 8 ones. Okay. Now, if I count, it has 8 ones, and this has 8 plus 8, 24 zeros. Okay. Uh, so if I calculate the number of host person, this is network person, and this is host person, where I can have number of hosts. Okay, so by default, 2 to the power 24. Okay, that where I will get 16 million hosts. Okay, 16 million host. I can have it in default class A CIDR. Okay, like this. If I calculate for class B, this is /16. So another 16 is available. So 2 to the power 16. Okay. Then it will come around 65,536, something like that. Okay. And if I come to class C, then my host person, if I see, yeah, 2 to the power 8. So hope you are all aware about subnetting. So this 2 to the power 8, I will get 256. 256. So host I can define this. Okay. Now I don't want to go with default class because In class B, if I want to have some 100 servers, from the creator subnet, it gives 65,536. But for my 100 server, if I use class B, then a lot of host range will be wasted. So for that, I need to go with CIDR. So if I want 100 server, or take an example, 1000 server I want, okay, then instead of going with the default class B range, I need to check it out with the CIDR for 1000 servers, which subnet mask I should go. Okay. So for that, I have given you a table. Okay, 1024 host is available. For that, /22 CIDR I can go. Okay. Now I want to go with class B and with the /22 CIDR notation. Then I will get 1024 host. Okay. If I go to this website, that will help me to identify the number of hosts and number of networks, and how to perform CIDR and the subnetting with this tool. 172.16.10.0/22. Okay, let's see. I want to go with this range. Okay, so what it says, host minimum and host maximum. So starting and end host range it has given. Within this, network address available, broadcast address is also available. Okay. Now what I can do for fulfilling the 1000 host requirement, I should go with this IP subnet range. Then the IP address will start like this: 172.16.8.1. then 8.2, 8.3, 8.4, then 8.254. The 255 is for broadcast. Then 9.1, 9.2, 9.3, like that till 11.1 and 11.2, 11.3, 11.254. Okay. So these IP addresses I can use, okay, for designing 1000 servers in the network. Okay. Now just go through this table. This will give you an idea. This subnet mask represented by this CIDR notation, and how many IP addresses I will get, nothing but the host bits. This will give you an hands-on, to pick up the number of host requirement with the CIDR notation with the subnet mask. Okay. This is a basic subnetting example. Let's come back to our AWS VPC networking. Okay, so I have taken this CIDR and subnetting. This will help me to enable to design my network for the requirement given by the organization. Okay, now I'm going to briefly tell you about these components and how this components works. We are going to see. Okay, now let us go to AWS console. And since I know how to design my physical networking, the same way, I have to define my virtual networking, okay, with guidance given by the AWS provider. You can go through AWS documentation. Before that, you should know which tool works at which level, and how should be controlled. Okay, everything we should be familiar. Okay, now. So as I said, what is subnets? Subnet is a subnetwork. The original class A or class B, class C is segregated with a smaller range with the CIDR. Okay, this is nothing but subnets, subnetworks. Okay, and a route table. Route table it is basically contains the list of rules, the routing. Okay, for those subnets, how to reach to internet, how to reach to other subnets, those and all. Okay, then internet gateway. Now I'll show you my height. Uh, Okay, routable I have explained. Then let's come to internet gateway. Internet gateway is basically a VPC component where if I want to reach internet from my subnet or the VPC, it is required. Okay. So this is my one of the subnet in availability zone A and another subnet in availability zone B. Okay, if this instance want to talk to internet, then through the router, it should be connected to internet gateway for the purpose of connecting to internet. Okay, so it is nothing but it provides the internet connectivity to your sub. Okay, then security group. Yeah, security group is an important one. So in AWS, we deploy EC2 instances. So those instances should be protected. Okay, when it access to, from internet or from other subnets or other VPCs. So the security groups will allow you to attach some software firewall, by defining the port number and the source IP address. Then this will secure the EC2 instance. Okay, so this software level will provide the security at the instance level. Okay, so it has inbound and outbound control. And the security group is especially designed for the EC2 instances to provide control access to the instances. We have another software firewall called NACL. So what is this NACL? Nothing but network ACL. In the traditional networking, we have seen access control list. So what is that access control list? It is a list of rules will be evaluated one by one till the bottom. So if the rule matches, then it will allow the traffic. Okay. If it doesn't have any rule, then it won't allow the traffic. Okay. So how we define the security for the instance level? This one we define the software firewall at the subnet level. Okay. So this network ACL sometime we use the default one or we go with the custom one. So this network ACL, it is needs inbound and outbound rules. So there are some differences also for the security group and network ACL. Both are called as software firewall in the AWS VPC networking. However, how it works, how it differ from each other, I have given a few examples. Okay, so for example, in the security group, I'll show a small example. In the security group, I have to define the inbound traffic. Okay, which traffic should be allowed. Okay, for example, if I want to allow some of the public IP from outside, then I'll give you an example. Yeah. So I'm allowing this particular IP for which port? SSH. Okay. And if I attach this security group to my instance, then my instance will be accessed by this server with SSH only. Okay, other services are not allowed. Like that, I can define the list of rules. So once I allow this particular machine to access my EC2 instance, I no need to define another rule, for the outbound traffic because it is allowed. That is called stateful. Stateful is nothing but it maintains a session for the incoming connection and it will respond to the incoming connection automatically. Okay. So if you go through this security concept, what is stateful firewall, what is stateless firewall, you will come to know so many things. Okay. Then elastic IP addresses. So what do you mean by elastic IP addresses? So if I want to deploy a server that is nothing but EC2 instance in the AWS, then it should be having a static public address. Okay. So by default, when you define a server attached with the public IP addresses, Amazon will give you a public IP. But when you reboot the server, or the server hangs, then while rebooting, the IP address of that server will change. Okay, so if I want to have some standard services, like this is my web server, and if I want to expose this server to the internet, always it should be having a static public IP addresses. The IP address should not change, because the IP address which I assign to the server should be mapped to a DNS name. For example, www.myorganization.com. Okay, always it resolves to the particular public IP. Okay, where the request will come from the internet. So the IP address should not change at any moment. For that only, I am attaching a static public IP address. Okay, so this static IP addresses, once I allocate, I should use. I should not leave that elastic IP address in the free pool, because it will be charged based on the hours. Okay, so the best practices, you can go through the AWS documentation. Yeah. Then NAT gateway. So what do you mean by NAT gateway? Previously we have seen internet gateway, okay, which provides the internet access from my instances, okay, to the internet. So if my subnet have 10 servers, if I attach to the internet gateway, then internet connectivity I will get from in and out. However, as per organization standard, some of the servers we don't expose to the internet. For example, database server, domain controller, file server, etc. So these servers are, do not want to connect it to the internet directly. Okay. So for that purpose, I should to go with the concept called NATing. What do you mean by NATing? NATing is nothing but mapping a private IP with a public IP. And in order to hide my internal network scheme, I should use the NATing concept. Okay, so that my servers will remain to have the private IP addresses, and if my servers want to access the internet uh, due to some reason, like upgrade the patches and downloading some packages and all, it needs internet. So I can attach a NAT gateway, okay, with the private IP addresses. It will get NATed to the public IP in the NAT gateway, and it accesses the internet. Okay, and nobody can access these servers directly, because it is attached to a NAT gateway, and it is still using the private IP addresses. Okay, yeah. Then we do have several other tools where we can develop our networking in the AWS. So those areas we are going to cover in details. For example, how to build site-to-site VPN. So from my AWS cloud to my on-premises data center, how to establish the connectivity. So for the purpose of migration, how to build a VPN. So those things we are going to see in practical. Okay. So some of the basic components I have explained, and on today's class we are going to see how to work on those tools to design my networking in the VPC of AWS. Hope this information is useful for getting the basics of networking in the AWS. So in the AWS networking, we are going to see a practical how to create a custom VPC, and under this custom VPC, how to create a different subnet. So I'm going to show you how to create a public subnet and private subnet. and how to deploy the instance, and how to enable the routing between these subnets, then how to enable, uh, I mean, how to attach internet gateway in order to allow access to the internet, and for my private subnet, how to attach a NAT gateway for connecting to the internet, and how to attach elastic IP to one of my EC2 machine in the public subnet. Uh, and yeah, many more we are going to see it today. So in order to practice this thing, you need to have AWS account. Hope you all have the AWS account created in the AWS web portal. If not, you follow the instruction how to create the AWS account, and there you can browse the VPC, virtual private cloud. There you can design your networking to build the virtual infrastructure. This session going to be helpful definitely. I hope. Yeah. During the next session, let us see the practical things, and I will explain all these topics, and let us build subnets and enable the routing, and yeah, enable the server to communicate each other and connect to the internet. Okay, hope the session is useful to you. We will see in the next class.